All right, so picking up where we left off, we have a large amount of code that makes a grid with 4 arrows on here. And the first step that we're going to do is take this grid code, which is all of this code, all the way down to here. We're going to wrap that in a function called grid. But for right now, if you would, take the screen, let's see, how do I want to do this? Take the screen section right here, it's just the W ends right here, do a Command X, and come way down here to the bottom, and type out a comment that says main, and then just a habit I have, I do a bunch of these hashtags, just to show you where the program kind of begins, and then I paste in the screen code, okay? So I just moved it from the top down to here. Okay, we're now going to take all this code. This is my Turtle South code. That's that last arrow that I did. And I want to highlight all the code that makes the grid. All right. And you want to hit tab once while it's highlighted. So again, I'm not highlighting this part, just all the code that makes the grid. I hit tab once. In front of that, I can now define this code, this entire block of code, as a function called grid, def space grid, and then empty parentheses followed by a colon. All right. Now, once I do that colon, I do get this little collapsible fold line, and if I click on that, that'll hide all of the def grid, and then there's my screen showing up. So it's a great way to take some code that you already know does what it needs to do, give it a name, in this case grid, and then indent that code inside of a function definition header, and that code will execute when you call it. So to call that function, you got to come down here. And all you do is, hey, I want to run that grid. So now what happens, the program's the same, it made a screen and now it's doing the grid. All right, so that's just called wrapping something in a function, and what's really nice is I can collapse this now. Okay, so the next thing that we're going to do is place some points on the grid. Okay, and we're going to write a function that does that, and we're going to call that function down here. So I'm going to do something like place point and say, hey, I want that point at 1, 1. And I'll do another one, place point. I haven't written this function yet, 4, 5. So if we tried to run the program right now, it would complain that place point's not defined. Let's define it. So we go way out to the top of the program. I go to my import statements and say import turtle, hit enter a couple of times. It pushes everything down. And now I'm doing def space place point. And it takes in 2 numbers, x and y. And then we're going to place a point at that spot. To do that, we need a turtle. So I can say t is assigned the value of lowercase turtle. That means go into that file called, when we do import turtle, it brings in a file called turtle.py. Well, in there's a function that makes a regular turtle. So it goes like that. And let's see here. We want to put it in a certain spot, the point itself. Let's make sure it has the right shape. We're going to make it a circle. And the size, it's pen size, I'm going to make 5. And what color would you like your dots? I'm going to say t.color. But I want the user to tell us what color they want these dots. I might do something like this. I might say, hey, I want it to be red. And in both cases, I'll make them red. And I can pass to it any color as long as I say, hey, when they come in, I'm going to refer to it as the word color. And so now right here, I just put in the word color. So if they said pink, it would come up here. That becomes pink, and that would be pink. Let's see here. We now need to pick up its pen so it doesn't show that it's drawing anywhere. We move it to where we want it to be. That's a go-to. Now it turns out if I said put a point at 4, 5, it would only go over 4 pixels and up 5 pixels. It'd be about right here. 1, 2, 3, 4. Well, if you recall, these are 30 apart. If you go back to the grid here, we were reducing x and y by 30 each time, or incrementing it, please. Sorry. So we got to multiply both the x and y by 30. So you can say, hey, x times 30, and then y times 30. And that will get it to go to the right spot on the grid. And now we can put down the pen. I don't think we even need to do that. It's just, there it is. I think that'll work. So now if I run it, I should get 2 points. Let's see. Yeah, I get 1 point at 1, 1 and another point at 4, 5. Okay, we're trying to find the distance between these 2 points. Well, it turns out if you find the difference between the x-coordinate here and the x-coordinate here, that will get you the difference between here and here. And if you do the same thing for y, you subtract this y-coordinate from that y-coordinate, or excuse me, take this number and subtract from it that y-coordinate, that'll give you the rise, and that's 4. Okay, so this is a classic 3, 4 triangle. When again you drop, you go down 4, and when you go over to the side, it's 3. And we're trying to find this distance. Well, this is classic 3, 4, 5. This will be, the distance will be 5 right here. So we work with known values in the beginning. All right, so now we have something called place point. And I'm just going to get rid of some extra spaces here. It's a good idea to have one empty space between your function definitions, okay? Alrighty, well, what we want to do now is find the distance between these 2 points. Now, before we go about doing that, it's probably a better idea to refer to the points that we're making as variables. x1 is 1 and y1 equals 1. That's this guy right here. So now I can change this to x1, y1, and then x2, y2. That would be 4. And then y2 is 5. So now I can refer to that as x2 and y2. Just make sure it does what it did before. We're just using variable names for the coordinates. Oh, we haven't done place point yet, so it's probably freaking out about that. Yep, it has no idea what place point is. So what I'll do is well, it should have, what's wrong here? Ah, there it is. I missed a comma there. That's what making it not run. Yee. Hard to find your own errors, isn't it? So here, there, I just want to make sure the points are in the right where they need to be, and they are. Alrighty, now we're going to do something called find distance, and we haven't written this yet. So I'm just going to write the function. And it's going to actually take x1 and y1 and x2 and y2. And it's going to return the distance between these 2 points, which is what we're trying to find. So what I'm going to do is copy this and go up here, import turtle, push that down, def paste space, colon. All right, so we're going to try to find the distance between these 2 points. Now, I want to draw a line in addition to showing the distance. The line's going to be a little bit different because, again, I've got to take into account that each one of these is 30 pixels. So I'm going to take the moment to do an adjusted x1, and that's just x1 times 30. And do that for the other coordinates. So there would be an adjusted y1, and it equals y1 times 30. And then I got to do that for adjusted x2 and y2. This way I can use these variable names for the distances and when we're trying to draw. And then I can use the regular variable names to do the actual math for the Pythagorean theorem. So now I want to draw a line from one dot to the other dot, preferably the second dot to the first dot. And so I'm going to do a turtle, use a turtle for that. And I can use the same variable name as I use down here. This t is completely different from this t because they're both in separate functions. All right. So this one is a pen size of 5. What color would you like your line to be between these? I'm going to do something pretty gaudy here, maybe do lime. And so I need to pick up my pen to go somewhere without drawing. And let's start at the second point. So I'm going to use a go to go to x2. Oh, excuse me. I want to go to adjusted x2, adjusted y2. Okay. I put down the pen and now go to the other point. And so that would be x1, y1, adjusted. So that should draw us a line between these. Right. And that would work for any two numbers that we pass to this function. But now, oh, it looks like there's a turtle right there. We could hide him real quickly. Say THT, so you don't see that turtle anymore. Now we need to actually use the Pythagorean theorem to find distance between these 2 points. Just writing myself a note there. So to do that, you find the differences of the x-axis. So delta of x, the differences of x. So that would be x2 minus x1. And then the difference of the y-coordinates, so that's delta of y. And that would be y2 minus y1. You always want to go in the same direction on these points. And c squared now is simply a squared plus b squared. You can think of this as a, and this is a b. So a squared dx, you could say squared like this, that works, dx to the power 2, plus b squared, so the difference is a y, delta y. I could do, again, like that, or I could simply say dy times dy, that's the same as squaring it. Now c squared is holding the sum of the delta of x and squared and the delta of y squared. Well, this is 3, and this side's 4. A squared plus b squared. So 3 squared is 9, 4 squared is 16. 16 plus 9 is 25, so it's holding 25 right now. To find out what c is, that's the real answer, is we gotta find the square root of c squared. So you can go into the math module, and to do that we need to first import it, so import math. And so we go into the math module, and in there's a square root function, sqrt, and you pass to it what you're trying to find the square root of. In this case, square root, c squared. Excuse me, the c squared, you're trying to find the square root of that. Here's a little animation that kind of shows you, let's see if I have it open somewhere. Yeah, right here. This is a program I wrote that kind of explains. So you start with these 2 points. You subtract the x coordinates, that gives you a 3 in this case. Subtract the y coordinates, that gives you a 4. There's your rise and run. You square both the a and b sides, if you will. If you add a squared plus b squared, it equals c squared, which in this case is 25, 16 plus 9. I'm showing you the little blocks here. And then you find the square root of 25, which is the distance between these 2 points. In this case, it's 5. Okay? I'll let it run out. So c squared equals a squared plus b squared. So anyway, that's what we're trying to do here. Now we've got the c here, and that's the distance between these 2 points. And so we can simply say print the word distance and followed by the variable c. And now this should tell us the distance between these 2 points, which is 5.0. And there you go. There it is. It works for any numbers. Here's the last part I want to show you, is that we could have these numbers be put in by the user, or you, if you were doing a homework assignment, And here's how you would do that. You'd use the input statement here instead of hard coding the number, and we ask for them to enter in x1's coordinate. When they do that, we need to convert this to a decimal number, and the way we can do that is with this following code. What this does is it turns it into a float, which is a decimal number, which is what we want. And you'll have to do that for every other number that we bring in. So if you really pay real close attention, you could copy this, and now this is y1. So I make sure both of these are y1, and this is y1, and that is y1. So this takes in x1, converts it to a floating point number. This takes in y1, the second coordinate, and that converts it to that, okay? So I'm going to copy this whole thing. You can get in trouble here, so be careful. I'm going to do the same thing for x2 and y2. So this is x2 now, x2. This is y2. That's y2. And we're saying, hey, give me x2. We convert x2. Give me y2. And convert y2. Now all those are something that we can enter in ourselves, and we have a homework helper. So now it begins with a prompt after it draws the grid. What's x1? Oh, that's 1, 1, and then y1 is 1. x2 was, let's say, 4, and y2 was 5. Again, it draws those and shows us the distance, and that's what we're looking for. So it's kind of neat because now you can put in any numbers that you want, and it should provide the solution of the distance. Now, when I say any 2 points, I mean it. So if I said 6 on the x and 3 on the y for the first point, and then maybe I said minus 5 here and minus 3 here, it puts those 2 points and shows me the distance between those 2 points using the Pythagorean theorem. And so that's the assignment. To turn it in, share with me this URL, and either via email, or you could just put it in the turn in. You can just paste it in and hit turn in. But anyway, you can get that information to me, that'd be great. So thanks for giving this a try. It's a lot of fun. It's a great homework helper. You can take in you can put in any 2 points, and it'll give you the distance between them. It's pretty cool. Thanks.